Let's get started with our tutorial on creating a new project in GeoIntegrate. To begin, we are currently on the Home tab. From here, there are two ways to create a new GeoIntegrate project. First, you can navigate to the GeoIntegrate tab at the top, click Create, and then select New Project. Alternatively, you can go to the Modules panel on the left side, select GeoIntegrate, and a new window will appear. From there, click Create and then choose New Project. Once selected, a new project window will open and you will be directed to the Project Data window. The Project Data window is where you enter the general information for your project. Here, you will see input fields for project name, project number, client, and project address. Simply fill in the required information. In addition, you can select your preferred display units in this tab. You may choose either SI units or English units. At the bottom of this tab, you will find the exploration list. A default exploration is already created, but it does not yet contain any data. To edit it, click Edit. This will open the exploration settings window. Begin by entering the exploration ID. Next, select the exploration type, either boring or test pit. Then enter the exploration depth and boring diameter. After that, input the start date, end date, and the status of the boring. Please note that the end date cannot be earlier than the start date. If it is, the system will display an error message after you save, as shown here. In addition, if the status is set to drilled or logged and the end date is later than today's date, a warning message will appear at the top of the page once you save. Once all information has been entered, click Save to confirm. You can access the map view here to see the boring locations displayed based on the coordinates that were previously entered. From there, you can also create a section view for them. For example, with these three pre-filled borings, you can open the map view and see them plotted directly on the map. Please note that we'll cover the section view feature in a separate tutorial. Note that you can share a project with team members using this share button. Now let's click Proceed to move to the exploration window. The exploration window contains multiple sections where you can enter detailed field information. These sections include general, stratigraphy, field tests, samples, groundwater, well and backfill, and remarks. Let's start with the general section. The general section is divided into 4 groups. The first is the team group, where you can enter the driller name or company, the person who logged the boring, and the reviewer of the log. Next is the location group. Here you can enter the latitude, longitude, elevation datum, and surface elevation. Alternatively, you can simply select the location from the map and the latitude and longitude will be filled automatically. The boring location information you entered here will appear in the map view that we reviewed earlier in the project data window. The third group is exploration equipment. In this section, you can specify the equipment used, the drilling method, hammer type, hammer weight, and hammer efficiency. The drop-down lists you see here can be modified. You can add new options to the menu or set any option as the default in the General Settings tab within the GI log configuration window. Also, all drop-down fields either here or in other tabs allow you to enter your own text in addition to selecting from the available options. We'll cover the general settings in a separate tutorial video. The final group is log customization. Here you can select a PDF template for the boring log from the available template list. Alternatively, you can create your own template in the GI log configuration window. Once created, it will appear in this list. We will discuss the template designer tool in a separate tutorial. The default setting for depth per page is 30 feet, but this can be adjusted to suit your project needs. If the selected template includes a custom footnote, a field will appear here where you can enter the footnote you would like to display on the log. Next, we move to the stratigraphy section. Under the stratigraphy tab, you can enter both soil and rock stratigraphy data. Let's begin with soil stratigraphy. To add a new soil layer, you have 2 options: import data or add row. If you choose import data, you can download and use the given Excel template here. Simply enter your soil layer information into the template and import the file into the system. If you prefer to enter the data directly, click Add Row. You can insert multiple rows and control exactly where each new row appears. Now, let's add a new row. Then enter the start and end depth, stratigraphy unit, hatch pattern, separator line, USCS group symbol, soil type, density or consistency, color, moisture condition, cementation or induration, plasticity, and any additional comments. All selected information will automatically appear in the description column. However, if you manually edit anything in the description column, the autofill function will be disabled. To reactivate it, simply click this reset button. The reset button will reset the description to the most recent description order if it differs from the existing one. Keep in mind that the description order displayed here can be customized in the GeoIntegrate configuration window. Even after the description column has been filled, you can update the configuration at any time. Just click Reset and the latest description order will be applied. You'll also find other formatting options here, including bold, italic, underline, and text align. Any formatting you apply in this cell will appear exactly the same in the final log output. Two helpful tools are available here, the Density Assistance tool and the Classification Assistance tool. The Density Assistance tool allows you to select a layer and either enter an N60 value to receive a suggested density and consistency, or enter shear strength to receive a suggested consistency. Both are based on AASHTO guidelines. You can choose the desired result and click Plugin, and it will be added automatically to the density or consistency column. The Classification Assistance tool classifies soil using particle size distribution and plasticity data in accordance with ASTM D2487. For example, if you enter 16% gravel, 20% sand, and 64% fines, the system will display all the possible classification options for you to choose from. Once more information is entered, such as a liquid limit of 20 and a plastic limit of 10, the list is refined. Simply select the result and click Plug In to apply it to the USCS and soil type columns. Click Save. For rock stratigraphy, the process is similar. A range of rock properties can be selected here. Please note that soil and rock layers cannot overlap. For example, a soil layer here extends from 0 to 5 feet. You cannot define a rock layer that overlaps any portion of that same depth interval. Next, let's move on to the field test section. In this section, you can enter field test results that will be shown on the final log. The available tests include the standard penetration test, cone penetration test, pocket penetrometer test, Becker penetrometer test, dynamic cone penetrometer test, vein shear test, and pressure meter test. Starting with the standard penetration test, or SPT, you can either import data from an Excel template provided by the system or enter the data manually by adding a new row. After adding a row, enter the start depth and the field blow counts, including N1, N2, N3, and N4 if applicable. The system will calculate the N value using the N2 and N3 blows. To calculate N60, you need to enable the SPT correlations option and enter the hammer efficiency, sampler type, borehole diameter, and rod length. Once these values are entered, the software will automatically compute N60. Please note that there is an additional correction factor here. 1 for the split spoon and 0.65 for the modified California sampler. This additional correction factor can be entered as any other desired value. You can also add to the drop-down options in general settings and also set a default value for it. Those two options are just a couple of cases provided by the software. You can enter cone tip resistance and sleeve resistance for the cone penetration test. Unconfined compressive strength and undrained shear strength for the pocket penetrometer test. Measured blow count NB, energy corrected blow count NBC, normalized blow count NB30, and the equivalent N60 value for the Becker penetrometer test. Penetration index for the dynamic cone penetrometer test. Measured torque, unconfined compressive strength, and undrained shear strength for the vein shear test. And finally, measured modulus for the pressure meter test. Next, let's move to the samples section. Here, you can enter information for soil, rock, and other materials. For soil samples, input the sample ID, sample type, symbol, and recovery data, including recovery length and recovery ratio. For rock samples, you can also enter rock quality designation, or RQD, including recovery length and percentage. The RQD and recovery ratios are automatically calculated based on the recovery length, RQD length, and sample lengths until they are manually adjusted. For other materials, use Other tab here. Always remember to click Save when you are finished. The groundwater section is where you record groundwater measurements. Click Add Row and enter the date and time, reading event. Check this box if groundwater was encountered. Enter the depth to groundwater and any notes. You can also choose whether this information should appear on the final log by checking Include in the log. Next is the well and backfill section. Add a new row to enter backfill data, including the start and end depth, pipe type and symbol if applicable, backfill material, and backfill symbol. Then click Save. The final section in Exploration window is the Remarks section. You can add any additional notes you want to appear on the log here. After completing the Exploration window, click the Lab Results button to move to the Lab Results window. This window includes sections for index tests, strength tests, deformation tests, and chemical tests. Let's review each section. Under the index tests, you can enter the sample depth range, sample ID, moisture and density results, gradation results, percent passing the number 200 sieve, and plasticity test results. Under the Index Tests section, next to the Import Data tab, you'll find the Lab Field tab. This tab is designed to help you review and verify your logs by identifying any discrepancies between laboratory results and field data. For example, the gradation results for the sample taken from 5 to 5.5 feet indicate that the soil is sand with gravel. You can check whether this matches the stratigraphy data by clicking the Lab Field QC button. As you can see in the Stratigraphy tab, the soil at 5 to 5.5 feet is classified as sandy lean clay with gravel, while here it is shown as sand with gravel. You can refine the classification by adding more data such as plasticity test results. Click Go to Stratigraphy to review and resolve the discrepancy. Under Strength Tests, you can enter both drained and undrained shear test results. For drained testing, enter the cohesion and friction angle. For undrained testing, enter the undrained cohesion. Under the deformation tests, you can enter consolidation test parameters such as over-consolidation ratio, compression index, recompression index, and coefficient of consolidation. You may also enter California bearing ratio and R-value data. Finally, in the Chemical Tests tab, you can enter corrosion-related test results, including pH, sulfate content, chloride content, and resistivity. Let's review the generated log. Keep in mind that only the parameters assigned in the selected template will appear in the final log output. That concludes our overview of creating a GI log project. Thank you for your interest in GI log.